All right, so picking back up at number 6 on exam 1 review, it says find the equation of the line in standard form that passes through the following points and simplify your answer. So standard form is ax plus by equals c, where a, b, and c are going to be whole numbers. So we don't want any fractions, but to be able to find all the a, b, and c, we could first start by finding the slope and y-intercept if possible. So I'm going to start by using the slope formula. M equals y2 minus y1 over x2 minus x1. And I'm going to label this. This is x1, y1, x2, y2. So let's plug the values in. So y2 we said was negative 2 minus, as part of the formula, y1 is negative 10 over x2, which is 9, minus x1, which again is 9. And let's simplify. A negative and a negative make a positive. Negative 2 plus 10 is positive 8. And 9 minus 9 gives me 0. Now, we can't ever divide by 0. This gives us something that's undefined. So my slope is undefined. What that tells me is we have a horizontal line. A vertical line, not horizontal. We have a vertical line. If we came up with the slope being 0, then we would have a horizontal line. But since the slope is undefined, we have a vertical line. And I could have come back up here. Look at your coordinates, 9, negative 10, 9, negative 2. What do they have in common? And we see here that both of them have the x value being 9. When one of your coordinates, when the x's are the same, that's going to automatically tell you that this is a vertical line. If the y values were the same, you would automatically have a horizontal line. So since this is a vertical line, it's going to pass the x-axis wherever these x values are, so at 9. So I have x equals 9. Didn't have to do very much work for that, but x is equal to 9. And again, we can see it doesn't matter what the y value is. Y could be negative 10, x is still going to be 9. Y could be negative 2, x is still going to be 9. Y could be 50, x is still going to be 9. And so this technically is in standard form. I don't have any fractions, right? 9 is a whole number. The a value is 1. And can you guess what the b value is since I don't have a y? B would have to be 0, right? Because that's the only way the y could have actually gone away. So 0 times y gives me 0. So it would leave me with just x equals 9. So this is our equation in standard form. And if it had been something like 3, negative 7, and 9, negative 7, something like that, then we see here that our y values are the same, and so we would automatically have y equals negative 7, and that would have been it, our equation in standard form. But this one, the x values were the same, so I have x equals 9. Okay. All right, so number 6, I have x equals 9. All right, so number 7, the following set of 4 ordered pairs below defines the vertices in counterclockwise order of a quadrilateral, so a 4-sided figure. So it could be a square, it could be a rectangle, we could have a little rhombus looking thing right here. Maybe not by the way that I drew it, but what's in common of all of these quadrilaterals is the sides that are across from each other have to be parallel. So both pairs of sides that are across from each other are going to be parallel, and that's true of all the quadrilaterals. Boop, boop, right? We see all of those are parallel lines. So it asks us, step 1, to find the slopes of the indicated sides of the quadrilateral and simplify your answer. So we want to find the slope of this first pair of lines, the side connecting 1, 0, and 3, 6. So to find that slope, we are just going to use the slope formula. So I'll let this be x1, y1, x2, y2. And so slope is going to be y2 minus y1 over x2 minus x1. So I get 1. 6 minus 0 is 6. 3 minus 1 is 2, and 6 divided by 2 is 3. All right, so now the next one, we want to find the slope of the side connecting these 2 points. So again, I'm just going to use the slope formula. So I'm going to label them x1, y1, x2, y2. And my slope formula is y2 minus y1, so negative 1, over x2 minus x1. So we have 4 minus negative 1. Negative and negative make a positive. So 4 plus 1 is 5. 9 minus 1 is 8. And that gives me 5/8. And now it asks me to continue on. We're finding more slopes. So of 9, 4, and 3, 6. Nobody stopped me, so hang on. 4 minus negative 1 and 9 minus 7. Boop. There we go. All right, so we have 4 plus 1 is 5, and 9 minus 7 is 2. So this is 5/2, not 5/8. Sorry about that. Hopefully you caught that and was wondering, what the heck is she doing? All right, so moving on, side connecting 9, 4, and 3, 6. Again, label x1, y1, x2, y2. Let's plug the values in. So I'll have 6 minus 4 over 3 minus 9 gives me 2 over negative 6, which is negative 1/3. So this is negative 1/3. And the last pair, 1, 0, and 7, negative 1. So x1, y1, x2, y2. So I have negative 1 minus 0 over 7 minus 1. Negative 1 minus 0, 7 minus 1. Yep. So I get negative 1 minus 0 is negative 1 over 7 minus 1 is 6. So I have negative 1, 6. It says to determine if the quadrilateral is a parallelogram, a quadrilateral in which both pairs of opposite sides are parallel. So for lines to be parallel, they have to have the same exact slope. We see that none of the pairs have the same slope, so automatically, no, this cannot be a quadrilateral. It cannot be a parallelogram. All right, so consider the following relation. Y plus the square root of x equals negative 2x plus x plus 3 squared. And we want to first rewrite the relation as a function of x. So as a function of x, very simply put, what this means is everything that has an x needs to be on one side of the equal sign. That's it. So looking through here, I see on the right, this has an x, this has an x, so those are good, those don't need to stay. On the left, I have a square root of x. This needs to come over to the other side with all the other square roots of with all the other terms that have x's in it. So this is a positive square root of x, so I'm just gonna subtract it, and I'll end up with y equals, everything else stays there, negative 2x plus x plus 3 squared minus the square root of x. And there we go. We've written this relation as a function of x. So we have, again, y equals negative 2x plus x plus 3 squared minus the square root of x. So step 2 says evaluate the function found in the previous step at x equals 1. So what that's telling me is x is 1. And by evaluating, that means I'm plugging 1 in for all the x values and figuring out what the y value is. So I have y equals, and again, x equals 1. So I'm going to replace all the x values with 1. So I get negative 2 times 1 plus 1 plus 3 squared minus the square root of 1. Just making that replacement. And now we'll simplify. Be careful about your order of operations. So parentheses is the first thing in PEMDAS. 1 plus 3 gives me 4, so I have negative 2 times 1 plus 4 squared minus the square root of 1. Inside this parenthesis, all I have is a 1, and when we say parentheses in order of operations, we're looking for, is there an operation I can perform inside the parentheses? And the answer here is no. That's why we didn't do anything there. So the next thing is exponents. I do have this little 2 right here, which means to multiply 4 by itself. So I have y equals -2 times 1 plus 4 times 4 gives me 16 minus the square root of 1. Now the square root is actually a hidden exponent. We could rewrite the square root with an exponent of 1/2. So the square root of 1 is just 1 because 1 times 1 is 1. So we have y equals -2 times 1 plus 16 minus 1. And we do have some multiplication, so y equals -2 plus 16 minus 1. So y equals, now I just have addition and subtraction, so I can do this from left to right. -2 plus 16 is 14, and 14 minus 1 is 13. So there we evaluated it. When x is 1, y is 13. So step 3 says to determine the implied domain of the function found in the first step. Express your answer in interval notation. So implied domain and domain are essentially the same thing. We're just looking through and trying to find, are there any x values I couldn't plug in? Any x values that are going to cause me an issue? So let's look at the first part, -2x. If I plug in an x value here, then I'm going to multiply it by -2. So think about, is there any number you can't multiply by a -2? Could I multiply negative numbers by -2? Sure, -2 times -5 is +10. -2 times -30 is +60. I can multiply negative numbers times a negative number, not a problem. Could I plug in 0? Sure, 0 times -2 is just 0. That doesn't cause any problems. And could I plug in positive numbers? Again, the answer is yes. -2 times 3, -2 times 50, -2 times 1,000,000. I'm not going to run into any issues here. So -2x isn't going to cause any restrictions. So let's look at the next term, x plus 3 squared. If I plug in an x value here, then I'm going to add 3 to it. Is there any number I can't add to 3? The answer is no. I could have -2 plus 3. I could have 0 plus 3. I could have 50 plus 3. I can add any number and 3. That's not a problem. Then once I add 3, I square it. So is there any number I can't square, which means to multiply by itself? -5 squared is 25. -50 squared is 2,500. 0 squared is 0. 10 squared is 100, right? I can square any number, negative, positive, 0. So again, this doesn't give me any restrictions. So let's come over to the square root. When I plug x in, I'm taking the square root. So are there any restrictions for the square root? What kind of numbers can't I take the square root of? Can I take the square root of positive numbers? Sure, and we have pretty numbers that we could take the square root of. We know the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, so on and so forth. So positive numbers we can take the square root of. Can I take the square root of 0? The answer is yes, because 0 times 0 gives me 0, so the square root of 0 is just 0. Can I take the square root of a negative number? What's the square root of -4? And the answer is not a real number, and we're not going to talk about imaginary numbers quite yet, but we can't take the square root of negative numbers and get back something real. So the restriction here, because of the square root, is that x must be greater than or equal to 0, right? It has to equal 0 or be some positive number. It just can't be negative. So this is my only restriction. So that will be the only restriction on the domain, but they want me to write this in interval notation. So I like to look at a number line. Here's 0. I know it can equal 0 because the little line below, so I'm going to put a little closed circle right here. That's 0. And everything greater than 0. So shading, which way do I shade? Greater than 0 implies that it's bigger than 0, which on a number line is to the right hand side. And if you're not sure about that, I can draw a little arrow in my inequality, and we see now that's an arrow, a little line gives me an arrow pointing to the right, so I know I should shade to the right. Now the arrow on my number line indicates that it keeps going on forever and ever and ever up to infinity. So right here I actually have the interval that they want. I'm going to start at 0 and go up to infinity. Since I have the closed circle from the equal to sign, this is going to give me a bracket. Infinity will always get a parenthesis. So my answer here is bracket 0 infinity parenthesis. Okay. All right, so number 9, consider the following function, h of x equals x minus 6 squared minus 1, and it wants us to find the vertex. This quadratic is in what we call vertex form. So vertex form is a times x minus h squared plus k, where my vertex is h, so the opposite of what's inside those parentheses, and k. K is just whatever is the number on the outside. So inside my parentheses, I have negative 6. So my h value is actually positive 6. And outside the parentheses, I have negative 1. So this is just my k value, negative 1. So there's my vertex. Just pulling it out of vertex form. So my vertex is 6, negative 1. Get that out of the way. All right, so step 2, find the x-intercepts. So finding the x-intercepts when the function is written in vertex form isn't too bad. So the equation or the function that we were given was f of x equals x minus 6 squared minus 1. And like we looked at with the linear function when we were trying to find the x-intercepts, we said to make the substitution y being 1. This one's written with function notation, but f of x is literally the same exact thing as y. So to find my x-intercept, I'm plugging in 0 for y. So I'm making that replacement. Y is 0, which really just conveys to I'm going to set this function equal to 0. So I'm going to have x minus 6 squared minus 1 equals 0. And now to solve this, x is stuck inside these little parentheses because of the square. So one of probably the easiest ways to bust it out is to undo the square. And we can undo a square with a square root. But in order to take the square root, this thing that's squared has to be all by itself. So I need to get rid of the 1. It's being subtracted, so I'm going to add it. So I get x minus 6 squared equals positive 1. And now since the thing that is squared is all by itself, I can go ahead and take the square root of both sides. So when I take the square root of something squared, that square and square root cancels out. I get x minus 6. And when we take the square root and we're dealing with a variable, we have to take into account that the value that I originally squared could have been positive or it could have been negative. So this is where the plus or minus comes in. And if any of you have ever done the quadratic formula, you know it's negative b plus or minus. This is why the plus or minus. So the square root of 1 is positive 1. So I could have positive 1, or I could have x minus 6 equals negative 1. So we're always going to take into account the positive and the negative. And now I have 2 linear equations that I can solve. So I'm going to add 6 to both sides, and I get x equals 7, add 6, and I get x is equal to 5. So my x-intercepts, we can write them as a coordinate. We plugged in 0 for y, so 0 is my y value. Here 7 is my x value, so 7, 0, and 5, 0. Those are my x-intercepts. Come back over here, find the x-intercepts. So 0, you can't see that, 7, 0, and 5, 0. And it says if any. So we just looked at the restriction of the square root. So if when we had gotten this piece that's squared all by itself, if it was equal to a negative number, so let's just pretend for a second that this had been plus 1, we would have subtracted 1 and ended up with x minus 6 squared equals negative 1. Now when I take the square root of a negative number is something imaginary. It's not a real number. So in this case, we wouldn't have any x-intercepts, right? So just be on the lookout for that. But here we do. 7, 0, and 5, 0 are x-intercepts. So it says find 2 points on the graph of the parabola other than the vertex and the x-intercepts. So how would I find 2 points other than the vertex and the x-intercepts? So I can come back to my original function, and they don't want me to use the vertex, so I can't use 6 for an x value, and they don't want me to use the x-intercepts, so I couldn't use 7 or 5. But to find other points, I can literally just pick any other x value and plug it in. So let's do 4. So if I plug in 4, This is h of 4 equals 4 minus 6 squared minus 1, and we can simplify that. 4 minus 6 is -2, -2 squared is +4, and 4 minus 1 is 3. So I plugged in 4 and I got 3 back out, so there's a point. And let's do another one. How about, I don't know, we want it to be small so it'll actually be on the graph, right? So how about 3? We did 4, let's do 3. h of 3 equals 3 minus 6 squared minus 1. So 3 minus 6 is -3, -3 squared is 9, and 9 minus 1 is 8. So I plugged in 3 and I got back 8. So there's 2 points right there. So it doesn't say that it wants us to graph it. It just asked us to find 2 other points, but I'm gonna go ahead and graph it because I feel like that's weird that they didn't ask for it. So I know at 7, 5, 6, 7, I'm at 0. At 5, I'm at 0. Our vertex was 6, -1. So at 6, I'm at -1. And then we found 2 points. At 4, I'm at 3. So 1, 2, 3, 4. There we go. And at 3, I'm at 8. So 3, that's 10, 9, 8 right there. And so we can kind of see the parabola coming to life. There we go. There's the graph of that, just in case they actually want you to graph it. All right, so moving on, number 10, consider the following function. We have g of x equals 5/7 x, the absolute value of x. And it says identify the general shape of the graph of this function. So since this has the little bars, this is the absolute value function. And the absolute value is always going to make a V. So looking at these graphs, the one that makes a V, this is absolute value. So anytime you see the little bars, you know your graph is going to have this general shape right here. Could you identify the other 3? If not, this one's linear, this is a cube root, and this is rational, just FYI. But the absolute value is always going to give us a V. So step 2, find 2 points on the graph of this function other than the origin. Express each coordinate as an integer or a simplified fraction. So we can find 2 points just like we did for the quadratic. The original equation they gave us is g of x equals 5/7, the absolute value of x. So to find 2 other points, I just need to pick some x values and plug them in. So I kind of want these to be pretty. This fraction right here is dividing by 7. So if I had a multiple of 7 in here, the fraction would simplify to a pretty whole number. You don't have to pick numbers that way, but I'm going to. So I know if my x value is 7, so if I did g of 7, I'm going to have 5/7 times the absolute value of 7. We talked about the absolute value. The absolute value of 7 just means the distance of 7 away from 0. 7 is 7 units away from 0. So the absolute value of 7 is 7. So I have 5/7 times 7/1. Multiply fractions straight across. So 5 times 7 is 35. 7 times 1 is 7. So this gives me 5. So I know if I plug in 7, I'm going to get 5. So I have that point right there. And I'm going to do -7. So g of -7 gives me 5/7 times the absolute value of -7. Absolute value of -7 is +7. So again, I have 5/7 times 7/1, which is exactly what we just did. So I know this simplifies to 5. So at -7, I am also at 5. So this point right here. That's the only transformation we had in this function is multiplying it by this number that's less than 1. So what that tells me is it's going to make my graph wider, but I'm not going to shift it left, right, up, down, anything like that. So it still touches the origin, and we could actually even see one reason why they said other than the origin, because it's still at the origin. And if I plug in 0, the absolute value of 0 is 0 because 0 isn't any distance away from 0, and 0 times 5/7 is 0. So again, it doesn't specifically say to graph this, but just in case it does ask you that, there's the graph right there. All right, and again, I'm going to stop and I'll pick up with number 11.